All right, welcome to All This Math. This is Professor Parker, and right now we're about to get into solving algebraically this system of equations. Now, what we have here is we have a quadratic, y equals x squared minus 2x plus 4, and we also have a linear equation, y equals 3x plus 10. Now, the thing about this is, if we were going to graph this, I'm going to just do like a quick and dirty sketch, right? So that would be our coordinate plane. And if we were going to graph this, I'm not sure. Okay, I'm thinking the vertex would be like right here. It would be upright. And it would be a straight line. The y-intercept would be 10. And it would be it would go upright because the slope is positive. So it basically would be something like this, right? It'd be something like that, right? So you got the curve like this, you got the parabola like this, and then you'd have a straight line going through it. So what that tells us is that the solution is going to be the 2 points where it cuts through the parabola, right? That's the solution. So in terms of solving this algebraically, what we're going to do is we're going to use algebra to figure out the coordinates of these 2 points. That's all we're really going to do. Now, one thing we should be thinking about is if we have y is equal to x squared minus 2x plus 4, and then we also have y is equal to 3x plus 10, we know that each of these expressions, this one and this one, are both equal to the variable y, right? And the variable y, whatever it is in this equation, is going to be the same thing in this equation, right? So what that means is that x squared minus 2x plus 4 must be equal to 3x plus 10. So one thing we can do is we can set each of these expressions equal to each other, or set each of these equations equal to each other, and then solve for x that way. So what that's going to look like is this. We'll have x squared minus 2x plus 4 is equal to 3x plus 10. And then what I want to do is I want to solve for x. So the way I'm going to solve for x is I'm going to put this in standard form. Standard form meaning I'm going to have all the x's and all the constants and everything on the left side of the equal sign. The only thing I want to have on the right side of the equal sign is a 0. All right? So this is what I'm going to do. I'm going to do minus 3x on the right, and I'm going to do minus 3x on the left. Now notice what I did. I didn't put minus 3x underneath of the 4. I didn't put it underneath of the x squared because those are not like terms. Negative 3x matches up with negative 2x because they both have x to the first power in the term, all right? Because we want to combine like terms, right? So now we have x squared comes down. Negative 2x minus 3x is negative 5x, or minus 5x. And then we have plus 4 equals, this becomes 0 because 3x minus 3x is 0. And then we have 10 left on the right-hand side. But I want to get a 0 on the right-hand side. So that means I need to get rid of this 10. Now, this is a positive 10. So the opposite of a positive 10 is, of course, a negative 10. So we got minus 10 on the right, and then I'm going to also do minus 10 on the left. And I always want to combine like terms. So I'm not going to try to subtract 10 from negative 5x. I'm not going to try to subtract 10 from x squared. Negative 10 matches up with the other constant, which is on this side, positive 4. So now I'm going to have x squared minus 5x, 4 minus 10 gives me negative 6, and now that's equal to 0. So now, I have a quadratic, right? And I want to solve for x. So I might be able to factor this. If I can't factor it, then I will use the quadratic formula or something like that. But I'm going to try to factor this. And from the looks of this, I probably can factor it. So let's see what happens. So I'm going to do my 2 sets of parentheses. Because I think because it's a trinomial and it's a quadratic, I'm going to try to use what we call the reverse FOIL method. All right, reverse FOIL method. So you write your 2 sets of parentheses, you put 2 spaces in each one, and first you take the square root of x squared. The square root of x squared is just x. All right, so those would be your factors of x squared. Just x and x. And then you want to think about what 2 numbers multiply to make negative 6, and at the same time add up to negative 5. So those 2 numbers, if we try, let's say negative 3 times negative 2, or negative 3 times positive 2, does equal negative 6, but negative 3 times plus positive 2 does not add up to negative 5. So we need to try another two factors. What other two factors? What about, let's see, negative 6 and positive 1. Negative 6 times positive 1 equals negative 6. And negative 6 plus 1 does equal negative 5. So now we got negative 6 and we got plus 1. So now we're about to be done with solving for x. But remember, we will have to go back and solve for y. All right? So keep that in mind. So we're going to have x minus 6 is equal to 0. And we'll have x plus 1 is equal to 0. If x minus 6 is equal to 0, then x must equal positive 6. Because you add 6 on the left, you add 6 on the right. 0 plus 6 is 6. Do the same thing over here. Subtract the 1 on the left, subtract 1 on the right. That leaves us with x equals negative 1. So these are two x values. And remember, we're going to have 2 points because this straight line, which is represented by 3x plus 10, crosses this parabola represented by y equals x squared minus 2x plus 4. It's going to hit it in 2 places. All right, it's going to hit it in 2 places. All right, so now I need to know my y values. So I need to know the value of y when x is positive 6. And I also need to know the value of y when x is negative 1. Now, it does not matter which equation we use. It doesn't matter, right? I'll just use the top equation just to see what happens. So y equals, I want to know what y is when x is 6. So that means in this equation, wherever I see an x, I replace it with a 6. I'm going to replace this with a 6, and I'm going to replace this with a 6. So now I'm going to have 6 squared minus 2 times 6 plus 4. And I'm going to do my order of operations, and I'm going to come out with a number, right? So 6 squared is 36. 2 times 6 is 12. So we got 36, take away 12. That's going to give me 24. 24 plus 4 is going to give me 28. All right. Now I'm going to throw that positive 6 into the second equation just to be sure. Just to be sure that x is valid for this one also. So what's 3 times 6? That's 18. 18 plus 10 is also 28. So that means that one of my points is going to be positive 6 and positive 28. X value, y value. Remember, in the coordinates, the first number is the x value, the second number is the y value, and you can remember that because the values are in alphabetical order. X first, then y. All right? Now, I want to know what y is when x is negative 1. So I use that again. I use y equals, let's do negative 1. Don't forget the parentheses. Whenever you plug in a number and it's a negative and you have to use an exponent, put that number inside parentheses like I did right here. So negative 1, not just negative 1 squared, because negative 1 squared does not equal negative 1 squared. Those are two different things. Two very different things. All right? Now, back to this. Replace that with negative 1. I got negative 1 squared minus 2 times negative 1 plus 4. So negative 1 squared is going to be positive 1. Negative 2 times negative 1 is plus 2. I know I'm doing more extra. I'm showing my work in this one. In this example, I didn't do that in the top example. Maybe I should have. But I'm going to show my work on this one. And plus 4. So now I got 1 plus 2 is 3. 3 plus 4 is 7. And then I want to make sure I get the same thing for y in the second equation, the linear equation. So 3 times negative 1 is negative 3. And negative 3 plus 10 is positive 7. All right, so my second point is going to be negative 1 and positive 7. And these are the two solutions to this system of equations. So really what these solutions represent is they represent the points where this line is going to cross this parabola. And that's how you solve a system of equations when you have a quadratic and a linear expression. Thanks for tuning in. Hopefully you learned something new. Please continue to send your math problems to the All This Math inbox, and your problem might end up on this board. Peace.